Hello, my name is Amir Priya. In this presentation, I'm going to evaluate three methods for calculating head office overheads in construction cost claims: the Hudson formula, the MDEM formula, and the newly proposed hybrid method called AAOAM. All analysis is grounded in JCT Design and Build 2016, alongside recognized cost management lecturer including Potts and Ankara, Ashworth, Pereira, Ross and William, Brooke, Hughes, and Murdoch, and the CIOB Code of Practice. A claim arises when a contractor incurs additional costs beyond what was allowed for at tender. Ashworth and Pereira explained that this is normally the result of employer-driven events, ambiguity, or change. Under JCT DB 2016 clauses 4.19 to 4.22, the contractor is entitled to recover direct loss and expenses when employer risk event materially affects regular progress. This includes prolongation costs, disruption costs, and head office overheads. As Hugh and Murdoch highlight, the contractor must evidence the cause, effect, and cost consequences clearly for any overhead claim to be valid. What are head office overheads? Head office overheads are the fixed central business costs needed to keep the contractor running. Ross and William describe these as management salaries, admin staff, HR, IT, rent, and insurance. Ashraf and Pereira point out that these costs continue regardless of what happens on site, which means they must recovered through turnover for all active projects. Brooke adds, when delays occur, the contractor loses the opportunity to earn overhead contributions elsewhere. This reduction is turnover is the central justification for HOOH claims. The Hudson formula. The Hudson formula applies the tendered overhead percentage to the contract value and adjusts it for the delayed period. Ports and Anchor note that its advantage is simplicity. It's quick, familiar, and easy to calculate. However, Brooke explains that tender overhead percentages often include strategic pricing, meaning they don't necessarily reflect real overhead requirements. Ashworth and Pereira argue that because Hudson doesn't use actual financial data, it risks inflating claims. Hugh and Murdoch also observe that its evidential basis is weak, which limits its accessibility is modern contract administration. In this example shown, Hudson produces a £100,000 claim for 50 days delay, based purely on the tender percentage. The Emden formula improves on Hudson by using actual overhead and turnover taken from ordered accounts. Ashworth and Pereira argue that this makes Emden more objective and transparent because it's based on real financial performance rather than tender assumptions. Ross and William also support this approach, highlighting that audit overhead give more accurate representation of business structure. However, Potts and Ankara warn that turnover can fluctuate significantly between years, which can distort the resulting overhead percentage. Towie adds that using Emden requires high quality financial data which not all contractors maintain. In the example, Emden produces an £87,500 claim lower than Hudson because it reflects actual financial ratio rather than tender percentage. Here on the table created, we can see that the two formulas going head to head. Hudson is easy to use but weak in accuracy and transparency. Emden has a strong eventual basis but becomes unstable when turnover fluctuates, especially during market changes or years of abnormal workload. Brooke, Ross, and William and Ashworth and Pereira constantly show the real cost behavior is too complex to be captured. through a single percentage figure. Hugh and Murdoch also urge that transparent evidence-based methods align better with the modern legal and commercial environment. This comparison demonstrates why neither Hudson nor Emden fully satisfy requirements of fair and accurate overhead recovery. To illustrate these issues, here are four practical examples. First, with the Hudson, example one is when the employer delays key design information under JCT clause 4.19. Hudson applies the tender percentage, which usually overstates the claims because it ignores the contractor's actual overhead position. Example 2 involves a brick type change that increases labor intensity. Hudson cannot recognize that labor productivity has changed, meaning the overhead allocation becomes unrealistic. For Emden, example 3 is a contractor with stable turnover across several projects. Here, Emden gives a fair overhead percentage because of the financial base is consistent. Example 4 is the opposite situation, a downturn year where turnover drops significantly, and then overhead percentages rise sharply, which artificially fluctuates the claim. These examples highlight that each formula behaves differently depending on the context. Introducing a hybrid method called AAOAM. It takes the good parts of MDEM using real overheads, but avoids the problem of distorted overturn by applying a weighted turnover figure. Then it adds a complexity factor to recognize that not all delays are equal. Some delays are simple, some massively disrupt the program. So AAOAM is basically a fairer, more realistic way of allocating overheads. It avoids the guesswork of Hudson and the instability of MDEM. AAOAM improves on both order methods. It's more realistic than Hudson because it's based on raw numbers and more stable than MDEM because it doesn't fall apart when turnover changes. It also recognizes the real-life complexity of variations, something neither Hudson nor MDEM even try to do. Overall, it's easier to justify, more balanced, and fits better with how claims are actually reviewed under JCT. In conclusion, Hudson and Emden provide useful insights, also significant limitations. Hudson is simple but weak, often leading to inflated or unrealistic claims. Emden is more evidence-based, but its resilience or turnover data makes unstable in fluctuating market conditions. The AAOAM method offers the most balanced solution by combining actual overhead, weighted turnover, and project complexity into a transparent and contractually defensible model. It aligns with modern quantity surveying practice recognized by academic theory and JCT DB 2016 requirements. This completes my presentation. I have also listed the references on the screen. Please feel free to pause and see. I've been Amir, and I hope you enjoyed the PowerPoint.